Everybody, and welcome to this tips and tricks video. My name is Dave Hideman. I'm the applications specialist for the steel segment here at Trimble, and we're doing another video on IFC files. Now, I've done a couple of IFC videos before. The first one was on just some tips and tricks of working with IFC files. When you get them, what do you do with them? How can you filter for parts in them and things like that? Then we also did a video on adding your own custom properties when you're going to be exporting IFC files. So instead of importing, we're dealing with exporting in that case. Today we're going to be taking a look at mapping. So why do we want to map properties in an IFC file? Well, we're getting these a lot of times from a different software. We're not talking about Tekla to Tekla, although that is of course possible, but we're getting these files from another software that maybe uses a different naming convention for its parts or for its materials. Now here I have a sample model, comes from another software, happens to rhyme with Schmevit, and when you bring it in, it looks like a model, everything looks great. And if I were to convert some of these parts, let me go ahead and select just a few of them. If I were to convert some of these parts like I've done in another video, Tekla has no problem identifying the shape of these parts. It's looking at that and comparing it to our shape catalog, and apparently the shapes in the source software look exactly like the shape name in our software, so Tekla can go ahead and make the conversion. Now, the material grades, not so much. Here we have a material grade called metal steel rusted. Now that, to us, doesn't really mean anything. That could be a paint finish, that could be just some sort of comment. When I apply these changes and we go ahead and close or hide that IFC file, when I double click on a beam, for example, we can see that the profile indeed was recognized as a 16 by 26, but then it comes in here as steel undefined. Now that's okay, we can fix it after the fact, but if we can get it to convert the right way, then obviously we can save ourselves a step and save ourselves some time. So we're going to take a look at mapping properties. Now this model, I don't really have any issues with shapes, so I'm not going to show you necessarily that, but we are going to take a look at the material grade mappings here. So let me go ahead and turn that IFC file back on. I'm going to first go ahead and select it. And then under the File menu, we want to go to Settings and then IFC Object Conversion Settings. So we'll give this a second to open up. Now it does have a couple of basic options here. Should we create a report after the conversion? Where should the handles be located? When we have a BREP object, so a BREP object is not going to be an extrusion, it's going to be a shape, kind of a blob. Now in this case, it's got a couple of options of how concrete or other materials should be handled if they are determined to be a BREP object. We have some primary profile mapping options, one being the profile name, which works well in my case here, but there's also the option to search by dimensions, where it will actually look at the shape of the wide flange member and then actually try to find which shape is the closest and choose it based on that. Honestly, I've never really had to use that. The profile name has always been kind of my go-to. So it's something you can test if you do run into profiles that aren't mapping properly, but I personally have never had to mess with that much. Now, when it does that side-by-side comparison, what it's actually using are some catalogs. We can come down here and click on the catalogs button, which will open the different catalog files that are being used. I'm going to go ahead and close this one here and this one here. So we have a materials list, and then we also have a profiles list. Okay, so this is what Tekla is going to be using as its sort of comparison when it sees a shape or a material grade here. So I'm going to move those over to my other screen, and to do the check, you just come down here and click on the button that says check. So I'm going to go ahead and click it now, but just be aware that that takes a few moments, and especially based on the size of the IFC file. So don't be too concerned if it locks up for a moment or two while it's kind of chugging through all of the shapes and all of the material grades. This is a good time to go get a cup of coffee, or go talk to somebody about that game last night and holy crap, did you see that? So I'm going to pause the video here because, like I said, it does take a few moments for it to do this. And then I will restart the video once we are ready for the next step. Okay? All right, so through the magic of television, now here we have the missing mapping that's popped up here. And I'm looking at my, my clock. I think about 4 minutes passed between me clicking that check button and this window popping up. So just want to reiterate, don't panic if your Tekla locks up when you press that button. There's a lot of data that it's chewing through to come up with this. So just be patient. Let it kind of work itself out, and eventually this window will pop up to tell you what it's found as it's interrogated that IFC file. So in this case, it's found some reference parts that look to me to probably be footings or some sort of concrete element. So you can see that they are shapes. It's not necessarily a B-rep. It is some type of dimensional property that it's found here. I'm not really interested in mapping those to anything, but this is also where you would see if there were a wide flange shape or a tube shape or an angle or something that Tekla didn't recognize, you could attempt to map it to an existing Tekla structure's profile. Like when I click this drop-down menu here, you can see all of the different shapes that are available for me to choose from. Now, when I go to the missing materials tab, I do have some issues here, as I showed earlier when I converted those few parts. So you can see I've got like metal steel ASTM A36 and metal steel A992, or that metal steel rusted that I was talking about. Now, those are not names for material grades in the Tekla world. So what you want to do is come over here to the material dropdown, and you want to start to search for that material grade. Now here's a frustrating thing for me, if I'm being honest, is when I look at this list, it is not in any sort of alphabetical order. It's just sort of a random dump of information. I'm not sure why it ended up this way, but it is what it is. I believe it is because if I bring back over this materials file, I think that's where it's reading from, because if you start at the top of the list, A786 550W, if I bring that notepad file back up again, we can see that's matching. So if you're having trouble finding a material grade in here, make sure you maybe click that catalogs button first so that you can use this to help find where it is in that list. That's just a little tip that I found when I was going through this. So for the materials that I had an issue with, the one that comes to mind was specifically this rusted, and those were beams, right? So I'm going to go down and I'm going to try to find A992 in my list here. There it is, A992 hiding away. And then, this ASTM A992, that's obviously also going to be A992. I'm not quite sure why in the source software that kind of broke it out that way, but it's not a big deal. Just keep an eye out for them. Come scrolling through this list. See if I can find A36 in here. There's A53. Of course, I don't need A53 for this one. Let's go back up to the top of the list and see if I can find that A53 here. And A992 again. There's A53. Okay. And let's see if I can find that A36. I know I saw it in here before. I may go check my notepad file and see where it ended up in this list. It's funny when there's a long list like this, you could scroll through a dozen times and not see it. Oh, there it is. Found it. All right. So, obviously there's more that I could do here, but I'm going to stop there. So let's update our mapping catalogs, and I'll say apply and then close this. So let's run that conversion on a small portion again. So I'm going to come in here. I never did do the HSS, so we'll just skip that. Let's grab these beams right here. Oh, make sure my selection is just to grab the few. And we'll run that convert IFC objects function. So once again, it's going to go through. It's comparing the catalogs and trying to see what matches what. All right, so once again, 1626s, it understands what those are. So let's apply those changes. Let's hide this IFC file and open up the properties. And here we have that beam is now, yes, a 1626, but it is also recognizing that it is an A992 material grade. So, like I said, we can convert all of those after the fact. I think in my video I maybe even show using the organizer to go and find those parts and then doing some cleanup work. But if you take a few moments and you map these materials and you map those shapes beforehand, you can really save yourself a lot of time, on the back end trying to fix all of those parts. So just a really quick example. Hopefully you guys find this helpful. If you have any questions or comments, go ahead and leave them below. Any ideas for other videos, go ahead and leave those below as well. We appreciate you watching, and we will see you next time. Thanks.